Hey, welcome back, everybody. I am Scott Ford. I'm going to be your host, your teacher for this very first live stream covering the CompTIA ITF Plus materials. Specifically, this one's going to take a look at software development. Now, I do have other videos on YouTube concerning ITF Plus. I'll probably wind up posting those live or not posting those publicly. Right now, I just use them on the back end for my students. But welcome. Also, before I get too far into this, let me see if I can find something very quickly. Had an individual reach out during the last live stream about he didn't have access to material. His teacher sounds like they were doing the best they could, but they just didn't have the materials for the course. And I totally get that. I'm a curriculum developer, instructional designer by design. I've been doing this for 20-something years. And sometimes schools don't exactly always have the best material. The teachers don't always have time to develop stuff. And so it can cause all sorts of trouble. And it's not the teacher's fault by any means. They have to deal with, the shortages that they have. So before I do that, let me move this over here. Let me make sure this is working correctly. I'm actually doing this kind of on the fly. I probably should have done this earlier. But what I'm going to do is, yep. All right, that works. Let me switch over so you can see the monitor. That is a QR code for our Discord channel. So this is the Discord channel that we have, and that's a QR code. So if you scan it, it should get you into Discord. And that is a great place where you can interact with my current students out here in the Houston area. We're out here in Humble ISD area that's northeast of Houston. And so you can interact with them as well as college students and some other folks that I have in the channel. So leave that up there just for a few more seconds, and then we'll move on. Oh, hello, Ireland. Welcome. All right. Let me switch back to my ugly mug. So what we're going to do today is we're actually going to look at software development. Now, to be clear, I am not a software developer. I'm not a coder. What we're doing is we're going to take a very quick, brief overview of software development that you need to know for the CompTIA ITF Plus certification. Okay, that's what we're doing here. So let me hop back over. If you were with us yesterday, I had a little bit of trouble with PowerPoint. It was crashing on me a few times. So hopefully that doesn't happen today. So software development. Here are the objectives. We're going to describe the purpose of algorithms, flowcharts, and decision tables. Identify and give the functions of common flowchart symbols. Explain the purpose of programming and programming languages. Classify popular programming languages into different categories. Now, this is a big one. For those of you who are going to sit for your ITF Plus certification, this is a big one. I had a student take their ITF certification, I want to say Friday, before vacation. We're on spring break out here, and that kind of ate his lunch. So we'll pay particular attention to the to that. I just got a request to share the Discord again. Let me pull that up for you. There you go. There's a QR code for Discord. I'll give you guys a second to do that. All right, let me hop back out of here now. So let me move the Discord QR code down. And let's continue on looking at the objectives. So classify popular programming languages in different categories. We just said that. List and define different data types. List and define common programming decision structures. Compare and contrast variables and constant identifiers. Describe, let me pull back my, there we go. Describe an array and vectors, describe functions, describe different programming objects, explain the purpose of pseudocode, and interpret basic examples. That's also another big one on the test. Describe the general steps and deliverables of each step of the Application Lifecycle Management process, that's the ALM, and describe and explain the testing procedures used in ALM. And again, I really want to stress this. This is not a coding lecture. I'm not a programmer. This is just the basics, the fundamentals for the ITF Plus exam, so you understand the general idea behind some of this. Also, I will add, software development and the other presentation we're doing today on databases are not on the A+ exam. This is specifically for ITF Plus, as well as the Tech Plus exam, which is a newer version of the ITF. So, also, before I forget, I got my Bones coffee mug with me. My Bones coffee, one of my favorite types of coffee. So if anybody from Bones is listening, All right, moving on to general software development. So software development is the systemic process of turning a software idea into a functional project, or product, I should say. It's developing software is composed of several steps, depending on your budget and scope, how big the program is. It can be one computer programmer up to a multi-person team of coders, project managers, quality testers, etc., etc., etc. So if you are, let's say, a little studio, you might have one coder, you might have two coders, right? Minecraft began as a passion project, as a sandbox project. There's other software out there that began as, one or two people working on it. And then you have the AAAs, right? You got EA. Wait a second. Ooh, I get sound effects for AAA. Let's see. For EA, I got a sound effect for EA. Here we go. The sound effect for EA.
Your feeble skills are no match for the power of the dark side.
There we go. I'm playing with my Stream Deck. So you have everything from a small mom and pop, shop to large national companies that are doing software development. And based off of the budget that you have and how big the project is will vary in how many people are involved in developing the software. So computer programming or coding is a process of creating software to solve a problem. Computer programmers, coders, are going to use programming language to create programs and software. A program is a series of instructions that tell the computer to do something. These are very small, separate commands that are executed one after the other. So, for example, to make coffee, well, put water in the carafe. I use a Keurig. Put a K-cup in the container, lower the handle, get a clean mug, preferably. Put creamer in the mug, put sugar in the mug, put the mug in the thing, lower it, blah, blah, blah. So these are a series of commands that are executed very quickly, and that is what computer programming is. It's basically taking a specific language, a special language, programming in that language to tell the computer to execute certain things in a very specific order. So we have something called a software development model. And a software development model is it's just a process of turning an idea into a final product. Now, if you are in certain professions, for example, I'm an instructional designer, curriculum developer, we have a model called ADDIE, and it's a very prescribed series of steps of how to develop a course. Everything from trying to identify if there's a need, kind of like software development. Is there a need? What type of need is it? What is our budget? How much of a time frame do we have? We have to look at our objectives for the development of the training. What do we want the person to do when they're done with the training? So software development has similar things. They have a series of steps that they have to go through in order to get a final product. And we have different examples of different models. We have agile, waterfall, spiral, iterative, and prototype. And these are all different types of models on how to develop software. Now, I will say this, just like in instructional design, we learn a basic model, and then we kind of take that basic model and we expand upon it. We find out what works for us. But even though, for example, my model of developing curriculum isn't found in a textbook, it is based off a very sequenced series of steps. Because if you go away from that, chaos can happen. You can completely lose track of what you're doing. Bad things can happen. You can go off your project. Your scope gets thrown out the door. Your timeline gets thrown out the door. And you eventually have a very angry client who doesn't like to pay you. So with that in mind, we're going to take a look at a basic model of software development called a waterfall model. This is what we typically use to teach the very basics of how things go. And so we have our requirement and analysis, followed by our system design, implementation, testing, development, and maintenance. Our requirement analysis starts with discovering that there's a problem. Hey, we have an issue here that we want to address. This step determines if there's a problem, what that problem is, and how to solve it. So let's say that we're working for a small company and we're having a problem keeping track of our inventory, as well as how much we're spending on inventory and how much we're making on the production of our stuff. So more or less, we're looking at tracking your inventory and tracking income and outcome, right? We're tracking our expenses and our receivables. So that's a problem. We know, hey, we have an issue here, and we might actually see if if there might be something else out there. How are we going to solve this problem? Do we need to come up with an in-house solution, or can we buy something, right? So once we get past the requirement analysis, what is this product supposed to do? How much time do we have to develop it? Then we start to go into the design phase. The design stage is used to create plans, models, and architecture of how the software will be implemented. We are coming up with our sketch of how things are supposed to be. When this stage is done, there should be a set of technical models and specifications. So the design phase is, we know we need this software package. We need to track our inventory, our income, and our output. Okay, what is that going to look like? What is the design of this going to be? What should we expect it to do? What should it do? What type of inventory is it going to track? What kind of currency, for example, are we going to work with? Are we going to work with the USD? Are we going to use something differently? How are we going to design this thing? So once we're done with our design, then we go into implementation and development. The design is used to create software code, databases, and other related content. So now we're actually creating our product. Now we're actually creating the software solution. And to me, we have a very similar stage in curriculum development and instructional design. This is the fun part. You're actually developing the product. This is where the excitement is. This is where the fun is. This is where you actually get to see your creation coming into life, which is kind of cool, which is why we do it. So implementation and development. Now comes testing. Testing is used to assure the quality of the final product. It can be performed at various phases of the development lifecycle. And as a general rule, you're better off testing throughout the development than just doing one big test at the end. So looking at, for example, instructional design and developing a curriculum, I'm going to test things along the way. I'm going to send it to our QA person or quality assurance person. I'm going to send it to our client. We're going to try to look at things before we get too far down the road. Because if you wait until things get too far down the road and you find an error, you find a mistake, you might have to redesign the whole project again. You might have to go through half the project. Now, let me give you an example here. I was subcontracted to do a project for Chevron, out here in Houston. And we were developing a course for the client, and we weren't testing it. The contractor on the contract refused to allow the end client to actually test the software, to actually look it over, to do quality analysis of it. Well, we pretty much got the beta, which is everything's put together. Now we're just doing final tests and tweaks. Well, they finally showed it to the client. Client hated it, hated every part of it, even the color scheme. So when we waited to that last minute to have it tested, and the thing was not approved, they didn't like the color, they didn't like the icons, they really didn't like anything about it. We had to start over again. And the problem was, at that point in time, I'd already done like 2 months worth of work on this thing at quite a bit of an expense, at quite a lot of hours. And so the end client, it was very costly. Now, to my defense, I did tell our contractor that he needed to show it to our Chevron person more than once, actually every week as I was developing it. And he said, no. So That was his bad. So that's testing, right? We're looking for mistakes. We're looking for errors. We're looking to find things that are broken. Then we have development, deployment. The product is launched. It's out there. The deployment could be for internal use only. For example, our budget example of inventory would be an internal use only, or it could be released out to the public. It could be released out to the wild. But deployment has now kicked in. How do we get it out there? Internal, commercial, what are we doing? And finally, no software is perfect. Nothing developed is perfect. This goes for pretty much any kind of creative process, whether it's software or a course or a book. You do all your testing, all this other stuff, you release it, and then you find a typo, or you find a mistake, or you find an error in the program. This is where maintenance is so important, because maintenance is going to keep your product up to date. It's going to find errors. It's going to fix things. You're either fixing security flaws, or you could be fixing things like functionality, or maybe you add additional things to the program, additional functionality. So for example, today I took a little bit of time because I am on vacation and I played a little Cyberpunk. Well, if you know anything about the Cyberpunk video game, you know that when it launched, it was not well received. When Cyberpunk was initially launched, it was buggy. It was not, people weren't crazy about it. But through the process of maintenance, through the process of updating problems, adding functionality, it has become an amazing video game. It's become a pretty good game. So that's the importance of maintenance versus, for example, software and products that aren't maintained, that start to get old, start to fall apart. The customer base gets tired of it. They walk away and they leave the product behind. So that is the waterfall method in a nutshell. Now I'm going to take a little bit of sip of coffee here while you look at that picture. All right, moving on. So let's, buggier than a McDonald's chicken. Good. So let's take a look at algorithms. Algorithms are ordered steps used to solve a given problem. It's a method for solving problems. And there's two commonly used ways that we map our problems and come up with our solutions. We have flowcharts and we have decision tables. So flowcharts, as you can see in the graphic, is a graphical representation of an algorithm. It's a document that presents a start to finish process that shows us our sequences. It allows us to map out what we want the program to do before sitting down to code it. Now, I will say this, flowcharts are very helpful when you can have multiple outcomes or multiple things that can branch off of it. Flowcharts can get very complicated very quickly. Before years ago, a few years ago, I think, I was developing a course for the U.S. intelligence community. And it was a graphic novel style training course, which was really fun. And we wanted to give the person, the learner, the person taking the course, kind of a simulation of choices. I really like BioWare. I like Bethesda. And so I really like games where you have these branches and these choices. And so we created a training with choices. And to keep track of all the possible choices, we had to create a flowchart. And it became very complicated very quickly. And so what I wound up having to do is make these false branches that ultimately led back to the main line, or you died. But flowcharts help you keep track of all these different decisions, all these other things. Now, there are some common symbols and meanings when it comes to flowcharts. The symbols used in flowcharts are usually standard. You can find them in different programs. For example, PowerPoint has them. Visio has them. If you're going to go into networking, you'll become friends with Visio, Word, and many others. So this one indicates the start or end of an algorithm. It's the beginning and end of your flowchart. This is a process or a computational operation. This stands for input or output operations. This is your decision-making operation. Yes, no, which way you're going to go with this. And this tells you, and this tells you which way you're going with it. So here's an example of a flowchart. And you can see that it gets very complicated very quickly. So here we have me waking up, okay? So the beginning of the process is wake up. Am I in bed? Yes. Well, then get out of bed. No. Okay. No, if it's no, then am I in the kitchen? If the answer is no, then I go to the kitchen. If the answer is yes, is coffee brewed? If coffee isn't brewed, then brew the coffee. If coffee is brewed, pour coffee in a mug. And then we have, does coffee have cream and sugar? If no, then add sugar and cream. If yes, drink the coffee. So that is a very simple flow chart, but you can see that it got complicated very quickly, and ultimately it still led to the same end of that algorithm. It still came to the same end of that flow chart. And it also illustrates that I might have a problem with my coffee consumption. So then we have decision tables. Decision tables are useful if the algorithm has a large number of conditions. It's more compact and readable format for presenting algorithms. It gives us a visual representation for specifying the actions to execute depending on the given conditions. And it's organized and displayed as decision logic. So let's take a look at a very, very basic, and I do mean basic, decision table. So we have our conditions and then we have our results. So it's kind of the same theme as the flow chart. Is it morning? Is it afternoon? Am I tired? And should I drink coffee? Is it the morning? Yes. Is it the afternoon? No, because it's the morning. Am I tired? No. That's a lie. Drink coffee? No. Is it the morning? Yes. It's the afternoon? No. Am I tired? Yes. Drink coffee. So you can see kind of this decision table and how it graphically represents these different decisions. So that kind of wraps up that portion. We're going to move on and we're going to talk about understanding programs. So hopefully y'all are keeping track. Again, this is basic stuff, the stuff that you need to know for the certification exam and kind of getting into computer science. So this is kind of below, I would say, intro to computer science. Okay. So moving on to understanding programming. So what is a program? A program is a series of instructions that tell the computer to do something. It gives instructions on how to get something done. So for example, a recipe for a chef. If you want to bake something, if you want to cook something, you can use a recipe. If you want to play music, you might use sheet music. That is a code. It is a program on how to make music. Or, let's say you're into fantasy, Dungeons and Dragons and all this other stuff. It's a spell book for a wizard. How do you cast magic missile or fireball? So a program, computer programs are separate small commands that are executed one after the other. These instructions could be a simple one line of code or lots and lots of individual instructions put together. It can be a simple program or it can be an insanely long program. So something like Angry Birds. Okay, something like Angry Birds when it first got started was probably a very simple program. There wasn't a lot of extraneous variables, right? There was still a good code, but compare that to, for example, Cyberpunk, or compare that to some modern AAA games. Those are going to have a lot more code to it than a simple game like Angry Birds or a game like Minecraft. No, not Minecraft. Minesweeper. I'm showing my age there. So these can vary based off of how complicated the program is. But remember, at the end of the day, the most important thing that a program is designed to do is to solve a problem. So let's talk about programming languages for a second. And before we do that, let's talk about actual human languages, right? The languages that people speak or not even speak. Languages can be spoken or signed. So you have languages that you can speak out loud, and you also have languages that you can use signs for, like American Sign Language. You also have languages that could be dead, or they could be fictional. For example, Klingon, right? Klingon is a fictitious language. but it follows the rules of grammar, and so it's considered a language. Or Tolkien. Tolkien created languages and wrote a book around his languages. These are fictitious languages, but are still actual languages because they follow certain rules for languages. Dead languages, for example. Latin is we use Latin for a lot of things as far as our root words, but nobody's walking around speaking Latin. So they can be dead languages, they can be fictitious languages, they can be spoken languages, they can be sign languages. Well, in programming, we have a lot of different ways to classify languages as well. And the two methods of classifying that we need to be aware of are low level, high level, and interpreted and compiled. So when we're taking a look at low level and high level, we have to think of something that we covered back in Unit 1 for digital literacy. And that is binary works in zeros and ones. That is how binary works. That is also how the computer processes information. Everything ultimately has to be broken down into zeros and ones that the computer can understand. And so when we're looking at low level versus high level, when we're talking about a low level language, we're looking at how closely it matches or approaches those zeros and ones, how closely it approaches machine language, which is what the language computer understands. A high level programming language or high level languages are closer to how humans normally communicate. So a high level language, by its very definition, should be easier for people to get because it is, again, closer to what we actually talk about. Now, here is a little graphic that we're going to build out. When we're done, I highly recommend taking a picture of it if you're going to sit for your certification exam, okay? So we start off with our programming language, where we have high level and we have low level. And like I said, we'll expand on this graphic as we go through. And I kind of just beat this one over the head where we have low level programming languages, right? This is the low level language, computer friendly. For this one, think machine language and assembly language. We humans typically don't like to code in these languages because they're hard to understand. This isn't how we normally talk. This is not how we normally write. Now, I'm not saying that there aren't people out there who love programming and machine language. There are, but the rest of us normal people prefer higher level language. We have assembly language. This is the language of the processors. It's a numeric language, and it's the lowest level language intended for a programmer to work with. Specific to a processor type, is designed to be used for an operating system and its functions. So here we have, I think I made a mistake as I was talking here. Sorry, that's supposed to be a machine language. My bad, there's a mistake down here. So yeah, this is supposed to be machine language. This is assembly language. So as we're looking at our graphic here, we have our low level, and in our low level, we have machine language and assembly language. So now let's start talking about our high level programming languages. Now, what I want you to do real fast is I want you to get your phone. If you have your cell phone with you, get your cell phone. And if you open up your cell phone and you look at, for example, your phone numbers, right? So I can pull up my phone and I can do this. Okay, Google, call Christy.
Okay, calling Christy Ford.
I'm calling my wife. I'm going to hang up on her. Don't tell her I called. But all I did was say, call Christy. This is my wife's name. And I didn't have to put a phone number in. But make no mistake, my phone still has her number in there. My phone isn't calling Christy on its own. It's going, okay, what number do I have associated with her? What is her phone number? And that's what they're using. Now, for me as a human with a high-level programming language, I just need to know what her name is to make the phone call. I don't have to worry about the numbers that make up that actual phone number. So this is an example of high-level programming language. I can put the name in my contacts. I can put the name in my phone. I don't need to put the phone number in. I just have to be able to put their name in. So that is high-level programming languages kind of in a nutshell. So learning how to communicate with zeros and ones can be rather hard. It's an undertaking. And so high-level programming languages were designed for programmers to have an easier time of it, to be able to understand the languages because it's more closely related to how we normally communicate. Now, I will add this. A lot of colleges and a lot of high schools will give you foreign language credit for learning programming languages, which is kind of cool. So if you're in high school right now and you need to take foreign language, check out your computer science program. That could be a foreign language credit. If you're in university or college and you need a foreign language, check out computer science. That could also count as a foreign language in a lot of places. So check with your counselors, check with your school to find out if it qualifies. So we have our high-level languages. Now we have something called interpreted and compiled languages. Now, before we get into the specifics of it, I want you to think about anime, right? Anime is animation originating from Japan. So things like Pokemon, Dragon Ball Z, Death Note, One Punch Man, and a lot more. These are animes, right? In an anime, you can either have subtitles or you can have it dubbed. So anime can either keep the dialogue in Japanese and give you subtitles, or it can swap out the entire Japanese dialogue so it removes all the voice acting and brings in English actors who speak English and create the verbiage all over again. So that's dubbed. So keep that in mind real fast as we talk about interpreted and compiled. Subtitles is like interpreted programming language, while dubbed is like compiled programming languages. So think of subtitles as interpreted, while dubbed, think of it as compiled. So our interpretation, or our definition or classification, I should say, of interpreted and compiled is based on whether the program is run directly from the program's instructions or if they need to be converted into machine language before it can be run. So, are we interpreting the language of the computer code of the program while it's being run, or do we compile it all ahead of time so it can all be run at once? So all high-level programming languages must be broken down into machine language, like I said earlier. Has to be zeros and ones. The differences between interpreted and compiled is how they do that. A compiled language directly translates the program so it can be run by the machine, while interpreted languages use an interpreter to read and execute the programming code. Hopefully that helped you make sense of those two. So taking a look again at our chart or at our table, we have our high level, low level, we have our interpreted, we have our compiled. Be aware that C and C++, Go, and Java are compiled. These can show up on the test. There is a reason I made this graphic. This graphic is to help you visualize these so you know where these languages are, because you could very well be asked on the exam, C++ is an example of interpreted or compiled, or which of these are compiled language or which of these are interpreted. So like I said, when we're done building out this diagram, this table, take a picture of it. So within interpreted, we also have subcategories, which is why you didn't see anything there. So within the interpreted programming language category, there are two subcategories that you should be aware of called scripting and markup language. So here's our diagram again. Here's our table so far. Okay. So in interpreted, we have scripting and markup. Scripting, interpreted languages that are typically used to create scripts run within an integrated development environment, an IDE, usually interpreted at runtime and not compiled. Examples of scripted languages include Bash, JavaScript, Perl, Python, and Ruby. Okay, so there's our table that we're still building out. Now, finally, our markup language is actually a fairly simple one to remember. If you've ever done web development, you've done HTML. What happens with marked up languages is we use annotated documents with tags. So for example, if we want to make something in bold, we have to put the tags in to make it bold or italics or whatever. So tags control things like color, fonts, alignment, links, and more. Examples of our markup language include HTML and XML. So I'm going to stop talking for just a couple of seconds. I'm going to have a little bit of coffee while you take a picture of this or screen capture this, because this will be extraordinarily helpful on the ITF exam. You need to know where these things live. All right, moving on. I just saw that YouTube put a commercial on me. That's pretty cool. Thank you. Make me that money, YouTube. All right, so let's talk about query languages for a second. A query is a question or inquiry. You have a question. You want or need to know something. So you might say, hey, I need to know how many gizmos I have in stock. You put that query in. You might say, hey, how many of these widgets do I have? Do I have them in the warehouse in Houston? Do I have them in the warehouse in Dallas? Where are they at? How much are we charging for them? How much do they cost us? Who ordered them last? So these are all questions that you can ask in the query language. And our next unit that will start out at, I believe, 7:30 is going to be database fundamentals, which is all about queries. Databases live on query languages. So we'll look at this in more detail. But query language is a programming language that is designed to work with databases. And like I said, databases we'll look at in at 7:30. So examples of query language include SQL or SQL, as well as XQuery. So if you want some fun, and if you enjoy coding, here are some resources that you can check out. Code Combat's kind of fun. You play this little game and you have to actually code in the actions of your avatar. You have W3 School, which is a very helpful website. I still use it to this day. And if you're 16 years or older and enrolled in a school, you can actually apply to be in the Unity student plan. Okay. How are we doing out there? Hopefully we're doing pretty good. Okay, we've been talking about for about 40 minutes. So the cool thing about this is once this is recorded, you can pause and come back, pause and come back. So let's hop into data types now. So data types, and we actually revisit data types in another unit down the road. I believe it's actually the next unit. If we take a look at these three versions of 7, 7, 7, and 7, they all mean 7, right? All three of these means 7. But from the computer's point of view, these are completely different things altogether. This 7 is different than that 7, is different than that 7. So data is information. Information can take many forms. So again, these three 7s are very different from the perspective of the computer. And we're going to see how that works. So a data type is a category of data. When working with spreadsheets, databases, or programming, we need to be very specific about the types of data we're going to use. And the data we look at in this particular unit are going to be those listed on the screen. In our next unit, and the database one, we expand upon this a little bit more. But for right now, we need to know what char, string, integers, and floats are. So taking a look at the character, the char. Char is an abbreviation for character. It could be it's a single character or single character variable. Now, 8 bits equals 1 byte, and we talked about this in Unit 1, but 8 bits equals 1 byte. A byte is a single character. It's A, it's B, it's C, it's 1, it's 2, it's 3. It is a specific character, okay? A string is when you group the characters together. Strings can either have a variable length or they can be fixed. So taking a look really fast at this table, on the left are individual characters, T, H, and E, and COFFEE. Those are individual characters, but we can make a string out of it. So the first one would be the, and the bottom one would be coffee. So characters versus strings. Then we have numbers. So 7, SEVEN, is actually a string made of characters. That spelled out version of 7 in the world of computers is not a number. It is a string. 7, the number 7 and 7.0 are numbers, but they are different numbers. They are handled differently. They're different data types. Okay? So let's see what's going on here. The first thing we have is an integer, otherwise called an int. Whole numbers that can be either positive or negative. They do not contain decimal points or fractions, and there is the key there. An integer does not have a decimal point. An integer is not a fraction. So the number 7, without anything behind it, is an integer, while a float has a decimal point. So the floats have the point 0, 0.1, whatever. Okay. Floats can also be divided into more types of floats. We're not worried about those for this course, but just be aware, we're kind of scratching the surface. There's always more to what I'm telling you than what I'm telling you because of the nature of the introduction. Okay. So here is kind of a summary. If we take a look at this table, on the left side, we have characters. Yes, 1 and 2 can be considered characters if you set them as characters. But if you want to do math with them, then you need to set those as some type of number. The string is characters put together. So my name is Montego Montoya. And if you don't know where that's from, then I feel bad for you. If you don't know where that line's from, that's Princess Bride. So, and then we have integers. Integers are whole numbers. There are no decimals. There's no fractions. So 1, -1, 42, 1701, 1701, I should say, are integers. While floats have the decimal. So 1.0 or 3.14 or 3.50. These are considered floats. I will say this, the exam, the ITF exam will test you on, what do you use for this? What do you use for this? Do you use an integer? Do you use a character? Do you use a string? Do you use a float? What type of number? What kind of data type is this? So you do need to know these as far as being able to use them practically. All right, so decision structures. You might also hear them called conditional code. Often we need programs to make decisions based on, and it just, guess what just crashed? If you said my PowerPoint, you would be absolutely correct. PowerPoint just died on me. So that's fun. I'm going to relaunch this. Yay. Good times. You hop back in here to, we're in decision structures, right? Pull that back up for you. Really wish I knew why it was doing that. But is what it is. Okay, so back to where we were a second ago, to decision structures. You might also hear it called conditional code. Often we need programs to make decisions based on the data it's working with. Yes, Ria, I think I've got a curse with PowerPoint because this did this twice on me yesterday during our command line conversation. So I'm not sure why it's crashing. I might have too many things running or something. Who knows? So decision structures might also hear conditional code. Often we need programs to make decisions based off of the information it's working with. And there are 3 types of decision structures that we need to be aware of for the ITF, and that would be Boolean, branching, and looping. So Boolean, there are only 2 values when it comes to Boolean, and that is true as well as false. Those are the only 2 values that we can have in a Boolean structure. Now, what's amazing is just with those two possible outcomes, we can still do insanely cool things with that. There's a lot of stuff we can do with just a true or false output. And here we go. We have what we call Boolean logic, where we have compares true versus false conditions. And there are more Boolean logics than I'm covering right now. But for us, know about and, or, and not. And is going to compare two values. Both values must be true for the statement to be true. If just one of the values is false, then the entire statement is false. So for example, if I am, and you can, by the way, do this in web searches. Let's say, again, I'm out here in Humble, Texas, which is northeast of Houston, and I'm in the mood for some queso. Okay, that's for those of you not in our area, queso is kind of this melted cheese. It's got to be yellow. White is just wrong. But yellow melted cheese, it tastes differently. It's kind of cool. And let's say I want queso. So I'm going to type in Humble and Texas and queso. The search results should be the search results if and only if Humble, Texas, and queso are in the results. If one of those isn't true, for example, it's not going to pull up, or it shouldn't pull up, barbecue places in Humble because I said Humble, Texas, queso. If it's not queso, it shouldn't pull up. So with an and statement, all of the values have to be true in order for the statement to be true. If just one of those is wrong, if one of those is false, then the whole thing is just not false. The whole thing is false. Or gives you more outcomes, gives you more possible true outcomes, because it's going to compare two values. And as long as one is true, then the output is true. So I might type in, let's see, Humble or queso. I'm going to pull up a whole bunch of results for Humble, Texas, and I'm going to pull up a whole bunch of results for queso, and they're not necessarily in the same area. Some could be, but I might find queso places in Arlington or Houston or Pasadena or Dallas or anywhere else in the world, actually. So, or as long as one of the statements is true, then the outcome is true. Then we have not. Not is a switch. It will do the opposite, okay? So it's going to do the opposite of the condition. It switches it over. So that's what the not statement does. And like I said a minute ago, you can actually use Boolean operations in web searches. So if you use Google or DuckDuckGo or Bing or whatever, if you type in capital and or not, you can do your searches based off of this, which is kind of cool. Then we have branching and the if statement. Branching is when a program chooses between options based off of one or more variables. Branch to different sections of code depending on true values or Boolean expressions. If statements is a common way to execute a branching decision. So if this, then that. If this is a value, then go here. It works with Boolean logic of the true or false. If a condition is true, then you do something. If the condition isn't true, then you do something else. So this is a little thing that I created in PowerPoint. I'm really hoping this doesn't crash. Okay, I'm going to do something. Fingers crossed. I'm going to show you a branching thing that I put together in PowerPoint. And behind each of the pathways, there's a little link to somewhere else in the PowerPoint. It's really cool. And I'm hoping it works and that it doesn't crash. But in person, this works. I've done it many times. So let's find out together. So which way do we go? Do we go down the sunny path, Or do we go down the do not enter? Well, I want to go down the do not enter path. So I'm going to click on do not enter. Uh-oh. Doesn't look like we're going the right way. Do we try again? Or do we keep going down the dark and scary path? This is an if. If I click this, then I go somewhere. If I click this, then I go somewhere else. Well, we want to keep going down the dark and scary path. Here we go. And we died. Okay. So that was a branching decision. If we click on this, then we go here. If we click on that, then we go somewhere else. So let's go back to the beginning and go down the sunny pathway and see what happens there. So I'm going to click sunny path. And oh, look at that. We got puppies. Okay. So what was going on behind the scenes was branching. It was if, then statements. It was do this, we go here, if, else, go there. So basic example of branching, you can actually do this in PowerPoint. Your path was determined by the choices you made. We have if, else statements. If the statement allows your program to perform one action, if the Boolean expression evaluation is true, and a different action if it's false. So if this is true, do X, else do Y, do something other. If you have Netflix and you're old enough, there is a special Black Mirror episode called Bandersnatch. Bandersnatch is insanely cool because it allows the viewer to pick their own direction during the story. It's like a choose your own adventure in a movie. It's really cool. Again, if you have Netflix and you know it's a rated M episode, so get parents' permission if you're under 18. I don't want to get any angry emails, but it's very cool as far as showing you the pathways that exist. Again, just really cool. Highly recommend checking it out. All right, so sometimes you need a program to run more than once. We have something called looping. Looping functions allow a program to run as many times as you need them to run. One complete execution of the statement within a loop is called a pass or iteration. So we have the while loop. The statement is repeated while your condition is true. So in other words, until the Boolean expression is false, it keeps going. So for example, a controller, a game controller. While you have your button pushed up, while you have your thumb pushed up on the controller, you're going to walk forward. Your character is going to walk forward. Okay? It's doing a while loop. While this is true, you're moving forward. Oh, you want to do shooting? You want to do automatic shooting? You hold the button down and it goes, doesn't stop until you're done shooting. Well, you hold the button down, and while the statement is true that you're holding that button down, your character will shoot. Okay? So that is the while loop. The for loop, back up one. Back up. The for loops combine all sorts of iterations. The goal is to make it a more readable code. Like the other loops, it continues until false. So it combines all three iteration expressions, termination conditions, and counting expressions. Now, if you want to have some fun, Minecraft actually has something called logic gates. And what we can do with logic gates is you can actually use redstone. Redstone in Minecraft is the power source. And power in Minecraft is either on or it's off. And so with that simple Boolean expression of on or off, true or false, we can do all sorts of cool things. So like I just said, Boolean logic on Minecraft Redstone, users can create logic gates. Users can create different type of logic gates. Some even have created rudimentary computers within Minecraft. And there are three that interest us that we just kind of talked about a little while ago, which is and, not, and or. And these are standard symbols for logic gates. So the and, like we said a minute ago, all conditions have to be true in order for the output to be true, or just one condition has to be true. and not is a switch does the exact opposite. So in Minecraft, if you want to create your own logic gates, what you need is just a lever or a lever, depending on where you're from, redstone, a block, and redstone lamp. And that begins the whole process with the input output. So clicking on the lever, should be clicking on the lever, misspelled there, turns on the redstone, which turns on the lamp. Not gate does the opposite. It flips it around. So it's a switch. So clicking on the lever calls, wow, I really have a major typo in this one, don't I? I just copied and pasted that mistake over and over again. Causes the inverse action due to the redstone torch. The AND gate means that all need to be true in order to turn on the lamp. And like I said, you can do some pretty cool things in Minecraft with these logic gates. Or either one has to be turned on. When I was teaching this in class, I would usually let the students have a day or 2 days to actually build things in Minecraft using the logic gates. And you can create some amazing interactions where you can do traps or elevators or trap doors or all sorts of really cool things based off of the power and, of course, the logic gates, which is kind of neat. All right, let's take a look at identifiers. So identifiers, well, before we get into identifiers, think about your driver's license for a second, okay? You have a driver's license, and on the driver's license are things that are common for every person with that driver's license. They're all going to have the same thing, right? They're all going to have something called the DL, a driver's license. They're all going to have an expiration date. They're all going to have a place for first name and last name. They're all going to have a place for hair color, eye color, weight, height, all this other stuff. Then you're going to have the things that change, like the person's name, like the person's weight, like the person's driver's license number. But you have things that don't change, and then you have things that do change. So the first one is your variable information. So your driver's license is going to look different than my driver's license if you happen to live in Texas. Your first and last name are probably different than my first and last name. Your date of birth is probably going to be different than my date of birth. Your address is probably going to be different than my address. These are variable informations that change based off of individuals in this case. Then we have constant information. This is going to be the same on every driver's license for that state. For example, you're going to have an issuing state. That's going to be the same. You're going to have a specific field for a picture. That remains the same. It's constant. You're going to have a space for addresses, et cetera, et cetera. So in a driver's license, you have variable information and you have constant information. Well, in programming language, in our world of identifiers, we have variables and constants. So programs need to be able to store data values in programming code. In programming, identifiers are used to assign names to different programming elements. So again, we have variables and we have constants. Variables are containers where items of data can be stored. The variable is given a name, i.e. an identifier, and stored by the code. The variable can then be called upon and used by the program. Variables can change based on the conditions of the programming code, and variables act as a placeholder for values stored in the computer. So for example, if you're coding a program, let's say that you want to calculate the age, okay? You own a retail store, you own a grocery store, and you want to be able to calculate whether or not somebody is old enough to purchase alcohol. They have to be 21 and older. You can have a variable called birth year or birth date. So you create this variable, you create this container called birth date. And then you're going to maybe have another variable called today's date. And today's date is going to automatically be updated based off of today's date. And you're going to have a program where the clerk will type in the date of the person, or they'll scan the card to get the date of the person, the birth date, and will automatically do the math for them. So the variables here are going to be the person's birth date as well as current date. The constant might be the age of 21. If they are not 21, if the result is not equal to 21, else no alcohol. If true, then they can purchase. So, and we can pull those codes in by the name. We can say, we're going to label this variable their birth date, and we're going to label this variable today's date, and we might have it where today's date minus birth date equals blah. So we name the variable, and we can pull the variable into our code. Again, constants, I think I kind of beat that over the head already, beat that with a dead, or beat that horse with a stick by now. Programmers can name, give identifiers to values that don't change. These unchanged values are constants, so they are called constants. I will say that doing a live feed for an entire unit is definitely different. Usually I'm used to student interaction and all this other stuff, but we're pushing through. If you're watching this after it's been recorded, feel free to pause as much as you need, take breaks, come back. I live in the world of YouTube now once this thing has been recorded, so I'll always be here. You can always come back and watch as you need to. All right, let's take a look at containers. So a container, an object that can store other objects that contain them. It's common to find an array or vector within a container. A container must be called a collection, might be called a collection depending on the programming language. And there are two that we need to be aware of, and those are arrays and vectors. And these do show up on the certification exam. An array is a collection of the same type of object that has a fixed maximum size. So, for example, okay, what did we just say? It's the same type of object that has a fixed maximum size. So let's say that I want to do let's say I want to count number of pies I have. Let's say I have a bakery, and I am going to create, and my PowerPoint just crashed again because reasons, right? Give me a second. I really don't know why PowerPoint is crashing on me like this. It just doesn't like it for some reason. All right, how about we do this? I am going to leave it like this. Not as pretty, I don't think. No, I want to run the PowerPoint. Give me a second. Sorry about this, folks. Was not expecting PowerPoint to be causing these issues. Do. There we go. All right, let's see if that fixes the problem. Okay, so containers, like I said, arrays and vectors. So let's say that I have a bakery, right? Let's say I have a bakery. Yeah, I know, Rio, it's a curse. So let's say I have a bakery, and I have blueberry pies, I have apple pies, I have raspberry pies, I have all these different pies. I can create an array of apple pies. And let's say that I'm going to have a maximum of 10 apple pies at any given point. I'm never going to have more than 10 apple pies in my store. I can make it an array. I know what the object is, apple pies, and I know I'm never going to have any more than 10. So I have the same object and a fixed maximum number that I can use. So if the array needs to hold more data, then the programmer must make a new array that is large enough to contain it. With arrays, the programmer can set aside specific space in a program. So that's one of the advantages of using an array, is I know how much space this particular thing can use. I know exactly how much it's going to use because I've capped the maximum number that we can use here. So I won't have 20 apple pies. I won't have 15 apple pies. I won't have 30 apple pies. I know that the maximum number of apple pies I'm going to have are 10. And so I make it a specific size you can max out here, which allows me to also guarantee the size of the program, or at least this part of it, because I have a fixed variable that I can control, that I know what size it's going to be. So arrays are preferred in systems with limited resources, for example, embedded systems. It basically, like I said, allows the developer more control over the size of the program, so things just don't go crazy big without, what happened here. Then we have vectors. Now, vector isn't necessarily the bad guy in an animated movie, for those of you who are Despicable Me fans. It's also a resizable collection of the same type of object. So, unlike the other one, a vector can have 10 apple pies, 15 apple pies, 20 apple pies, 1,000 apple pies. So there's no limit to how big they can be. So it can be resized, unlike an array, as needed. So here is a quick little table for you. I would highly recommend taking a picture of it in just a second, because there are questions on the ITF exam specifically related to which one does what and which one should you use if this is your situation. So here is the picture again, or here's the table. So an array is a fixed size, while a vector is dynamic. It varies with what you put into it. An array is going to be slightly faster access, while a vector is slightly slower. An array, ease of use is low, while a vector is high. And when you use an array, the size is known. It's critical performance requirements. While with a vector, you can have variable size, and it's more convenient because you can go, maybe we're going to have 10 pies, maybe we're going to have 15 pies. We don't want to put it in. We'll just leave it open as a vector. We probably won't get to that many pies. So you can have that kind of freedom and convenience. All right, let's take a look at functions and objects. So imagine for a moment developing a video game. The game has lots of different features, but there's something that happens over and over and over again. You don't want to have to recode that thing that happens over and over again. You don't want to have to recode the same thing, right? If you have weapons fire in a video game, you don't want to have to recode bullets coming out of a gun. You don't want to have to recode the sound of an explosion. You don't want to recode all sorts of things that happen over and over and over again. And so wouldn't it be cool if we could have something where we could pull information and not have to rewrite the code? Okay? If there was only a quicker way to do this, well, that's what functions do. Functions allow us to not have to recreate the wheel every time we do something. So a function is a piece of code, a subroutine within a larger program. The programmer can then access that function by putting something called a call. Okay, they're using a call, which is a request, into the functions library. It says, hey, I need bullets. I need the sounds of explosions. I need this. I need that. And so they're not having to recreate everything. They put a call into that library to pull that back into their program. This allows the program to reuse code and not have to rewrite it every time you use it. Okay? And by the way, you don't even have to write the functions. You can get functions out there. You can be part of different libraries. You can buy access to things. And so you can pull functions into your own program that you may not write. So let's say that you have this amazing thing that you want to use, right? Let's say you want to use the scream, okay, the Wilhelm scream. You don't want to have to recode it every time. So use it as a function, okay? So that's what functions do. Come on. Object-oriented programming. We do not go into this in any great detail. This, you can quickly get off the deep end on object-oriented programming. But object-oriented programming, OOP, is a programming technique that makes use of objects. It's not a specific code, but it's more of a philosophy of writing programs. It was designed to make programming easier. Objects are self-contained data structures that consist of properties and methods, and they are a group of common components. Objects, properties and attributes, these are the values and characteristics of an object, while method specify an object's behavior, the function that it can take on the object. What does the object do? All right, then we have pseudocode. Now, pseudocode is on the test. You're going to have to be able to interpret pseudocode and kind of figure out what they're asking you, what the results would be for your pseudocode. So pseudocode, first of all, pseudo means fake or false. Okay, pseudo comes from the Greek word meaning false. So it acts like something, but it really isn't. So pseudocode is something that looks like programming code, but isn't. So why would anybody use this? Well, you can make a draft, a practice run of writing actual code. It's much more friendly for a person to read and understand than writing in programming code. Now, let me clarify this. It's easier for the average person to read what's going on versus maybe somebody who lives and breathes code all the time, okay? People who live and breathe code can look at it just fine, I'm sure. But for those of us who aren't coders or aren't programmers, pseudocode makes life a little bit easier to read what's going on. So this is also a draft to work with. Allows the programmers and stakeholders to agree to the scope and deliverable of a program. Now, I just use a term maybe you're not familiar with, which is a stakeholder. Stakeholder are individuals that have a stake in a product or in a result or in something that's going on. So, for example, I'm a teacher out here in the district. We have stakeholders. Stakeholders are students, right? They come to school, they're expecting a good education. They're hopefully expecting to be able to, have a career or be on the path to a career when they graduate. So they're a stakeholder. Their parents are stakeholders, right? Because they want the best for their kids. The community, even if they don't have any kids in their schools, are stakeholders because the kids coming out are going to join the workforce. So these are different stakeholders involved in schools. Stakeholders, anybody who has an interest in the outcome of something, a product, a procedure, something like that, okay? So here is an example of pseudocode. I have named the program. The program's name is called Morning Coffee. I have defined a variable. I have created a variable called weekday. That is the holding thing for this. This is the barrel, okay? This is the bucket. It's called weekday. And weekdays equal Monday, Tuesday, Wednesday, Thursday, Friday. I have also created another variable, kind of a bucket, called weekends, and that is Saturday and Sunday. And now I actually write the code for it. If today equals Saturday, what's the output? What happens? Well, the output is drink Dunkin' Donuts coffee. Else, if it's not Saturday, else, if today equals Sunday, output drinking Starbucks. If it's not Saturday, if it's not Sunday, else output Keurig at school. So now it's a weekday, and then end program. All right, that wraps up. Ooh, we are close on time at 7:14, even with PowerPoint crashing twice. That wraps up our conversation about software development. Again, this is a very rudimentary conversation about software development. It specifically focuses on a lot of the ITF stuff that you need to know. The tables that I shared with you that I said specifically take a picture or a screen capture of, make sure to pay attention to that. Before I go, let me throw up our Discord channel one more time because I did have somebody reach out to me who wasn't my student, but I definitely want to help them because they don't have the resources that they said they needed. And so you can access the Discord channel. I have an entire website outside. Let me actually pull that up real fast while I'm talking to you all. Give me just 1 second. Let me pull that over there. All right, let me switch screens. All right. So real fast, here is the Discord QR code. Okay, if you want to get into our Discord channel, that is how you get into there. Just scan it. You obviously have to Discord on there. I will say I don't check it very often during school hours because our school district has decided to block it for some unknown reason. But what I can do is I can actually put you into my own Moodle site. And the Moodle site is mrfordsclass.moodlecloud.com. I've paid for this out of my own pocket, and I have right now the ITF course, Principles of Infotech. It's got everything there that you need in order to get your ITF Plus certification. Coming soon, Tech Plus, as well as a computer maintenance course. Part 1, I believe, is done, developed, with Part 2 on the way. So if you message me on Discord, I am more than happy, if you need to put you in the online course. I built it for my students that I teach face-to-face. I have a lot of faculty, staff, and community members involved, so I'm more than happy to let you get access to it as well if you're studying for your certification. But that is it from me. It's 7:16. Our next presentation will begin around 7:30, and it will be on database fundamentals. So I want to thank you all for joining me. For those of you joining me in about 15 minutes or so, I'll see you then. Otherwise, have fun studying out there, and goodbye for now.